Welcome to AP Physics Part 1. Before we get on with instruction, let's talk a little bit about this class and about what physics is as a discipline. What do you suppose these three phenomena have in common? The moon orbiting around the Earth, an apple falling from a tree to the ground, and the shape of distant galaxies or our own Milky Way. You might be able to guess that gravity is the force and the important principle that ties these three things together and explains all of them. How about this? What do these three things have in common? A car battery, a fastball, and about 1 billion gallons of water up behind a dam. You might be able to figure out that all of them possess energy. How about this one? Can you think of a college major that could result in a career as an astronomer studying the stars, or as an engineer designing bridges, or perhaps writing software for the game industry or for NASA, or as an oceanographer studying waves and ocean currents? If you've been paying attention and you signed up for the right class, you can probably guess that that major is physics. So what is physics? Physics is what Sir Isaac Newton called the system of the world. You can think of it as like the operating system of reality. It's what's going on under the hood and behind the curtain. Formally, it's the study of matter, forces, and how they interact with each other. It's also a really big subject. There's particle physics, theoretical physics, high-energy physics, condensed matter physics. Chemistry is really just a specialization of condensed matter physics. Astrophysics, and lots more. In fact, it's a big enough subject that it's been split up at the high school level and the AP level in particular into two classes. So what is AP Physics? AP Physics is the equivalent of a college-based, algebra-based physics course. So no calculus in either half of AP Physics. AP Physics Part 1 is part of a two-course series, if you want it to be. AP Physics Part 1 covers mechanics, motion, forces, gravity. AP Physics Part 2 is electricity and magnetism, thermodynamics, fluids, and nuclear physics. It's also excellent college prep. And preparing for college is the real goal, not taking the test to get out of college classes. But everyone's going to sign up for the test anyway, right? Because preparing for the test, setting that as your goal and working for it through the year, that is an important part of preparing for college. Who am I? My name is David Stroop. I'm going to be your teacher. I have a BS in physics from the University of Hawaii and a master's in secondary education. I've done a lot of things, depending on how you count. This is about my fourth career. I've been a reporter in newspaper and radio, a newspaper editor down in Clackamas County. I worked in marketing in the construction industry. Along the way, I've done freelance writing, published a couple of novels, editing, and cartooning. I'm married and I've got 2 kids. We all live down in Oregon City, and you're going to learn that I'm kind of a nerd. So what are we going to study? All right, and not necessarily completely in this order. Units we will cover include kinematics. That's basic motion, how things move, velocity, acceleration. And when we get to two-dimensional kinematics instead of straight-line motion, we're going to introduce vectors. Dynamics, that's Newton, all about forces, Newton's 3 laws, ways of applying it, friction, and how things interact with ropes and pulleys. Gravity, that's also Newton, is lumped into a unit along with circular motion because gravity causes orbits and makes things move in circles. So we're going to learn about the universal law of gravitation and how we can take what we learned from motion and forces and turn that into basic orbital mechanics. Energy is sort of like pressing the easy button on a lot of these things. And we'll learn how we can solve really complex problems using important concepts like work, power, and kinetic energy. You might remember kinetic and potential energy, but you probably didn't learn much about work, which is the really important concept that ties those things together. Momentum, that's more Newton. Talk about how things move and why you need a seatbelt and airbags to survive a car crash. Simple harmonic motion That's actually going to be a short unit that we're going to probably move in with another one coming up soon, waves and sound. Simple harmonic motion is basically oscillations, vibrations, things like pendulums. Rotational motion, that includes torque, while you need a longer wrench handle to tighten that bolt. The center of mass, rotational kinematics, angular momentum, why things that are spinning want to keep on spinning. Mechanical waves, including sound as a very important one. And then our final two units, which might sort of be grouped together, are electrostatics, which is charge, static electricity, and basic DC circuits, resistance, Ohm's law, the fundamentals of how you string elements together to make a circuit. In AP Physics, these things are grouped together around some important organizing principles. We'll talk more about what these mean as we go along. But first of all, there are 7 big ideas in physics. First of all, objects and systems have properties such as mass and charge. Some of these will make more sense as we go along. Fields exist in space, which can be used to explain interactions. For example, a gravity field, which explains why things fall down. Interactions of an object with other objects can be described by forces, in other words, Newton, pushing and pulling. Interactions between systems can result in changes in these systems. Changes that occur are constrained by conservation laws. You've probably heard of the conservation of energy and momentum. Waves can transfer energy and momentum from one location to another. And the last one, the mathematics of probability, can be used to describe the behavior of complex systems. Well, that's mostly thermodynamics, and we will actually cover that in AP Physics Part 2. In the labs we do, and we are going to find ways to do labs in this class, there are a set of important scientific practices that we want you to become familiar with. Using representations and models to communicate scientific phenomena. Using mathematics properly. Engaging in scientific questioning to extend your thinking. Planning and implementing data collection strategies. A lot of the labs we do will be less cookbook labs like some other classes, and more cases where you have the challenge to accomplish something and collect some data yourself without necessarily having all of the steps you need to take laid out for you. Performing data analysis, working with scientific explanations, and then connecting and relating knowledge across different scales and concepts. Do you want to know more about what we're going to be doing? Of course you do. So that's why one of the first things you want to do is to get a hold of the syllabus. The syllabus is a live document on our Canvas site. In other words, it's going to be updated as we go along. Here are some of the first steps that you can take. These are an important part of the syllabus. First of all, our textbook is a free online PDF textbook called College Physics for AP Courses from OpenStax. So one of the first things to do is to go on to the Canvas site or follow the links in the syllabus and download your copy. You're also going to need a scientific calculator, ideally graphing. It does not have to be one of the really expensive Texas Instruments models. Hopefully a composition book, which will be your lab notebook. And you're going to be asked about lab results on some tests. So it's important to have a lab book which is separate from your other notes. Got to have some way of taking and keeping notes. Exactly how you do that is going to be up to you. You should have a 3-ring binder with dividers to keep handouts, which may be in the forms of PDFs that you can print from home, as well as AP documents, lab write-ups, and tests. You're expected to maintain this, and you might be asked about it by your college. We also have a classroom set of Physics by Giancoli 3rd edition, which we'll have a chance to use, hopefully, if we get back together. This is the ideal breakout of how the grade is going to be. Tests will be about 45%. Lab papers and projects, when we are in person, are about 45%. So we're going to see how that develops with distance learning. Bi-weekly quizzes, pop quizzes, and other things will be about 10%. So it's mostly about tests and projects you do, and not about the homework, which is really for your study purposes, and the smaller quizzes and things of that sort. This is kind of important, the AP Physics equation sheet. It's going to be available to you all year long. If we get back together in person, I'll have printed out copies of it. You can find it online also. It's available on the AP test, so you get it on every test. In fact, the tests are largely going to be open notes, and since you get it on the test, mine as well as theirs, it's assumed that you will know all of these things. So make sure you have a copy of it and keep it handy during the class. Let's take a quick look at it. On one side, you've got a table of important concepts, constants, strength of gravity, speed of light, the mass of an electron. You've got tables of units and symbols, meters, kilograms, seconds, and also prefixes, like kilo means times 1,000, and milli means 1,000th. You got basic trig values, and we will be doing some trig, but with these basic values, you might be able to get through trig problems without actually having to hit the sine or cosine key on your calculator. And a list of the basic assumptions. These are things like ignore friction unless I say otherwise. On the other side, you've got more handy trig stuff. Like I said, we will be doing right angle trig, and you've got all of these basic equations and relationships here. You've also got the equations for mechanics, and you'll see that's the bulk of the course there. Everything from basic motion, velocity, acceleration, and time, all the way through gravitational potential energy, circular motion, kinetic energy, and the like. Waves, really just one equation, and then electricity, the basics of statics and also electric currents. So how about the AP test? Well, right now it's scheduled for 2 weeks in May. AP Physics 1 is going to be Wednesday, May 5th. AP Physics 2, May 7th. We don't know what's going to happen between now and then, but right now it is scheduled to be an in-person test. And with this much lead time, AP College Board has said that no matter what happens, it will be a full AP test. If you took an AP test last year, you might have noticed that you got a sort of a cut-down version of the AP test. They have said that whatever happens, this will be the full AP test covering all of the material. Is that really going to happen? No one knows for sure. We don't know if it's absolutely going to be in person or some sort of online thing, but we're going to prepare for it one way or another, and I will find a way, possibly through the AP support course we're working on, for me to be there with you to support you in this all the way to the end. The AP test, Part 1, multiple choice. You got 90 minutes. There are 50 questions, 4 possible answers for each one. You can go ahead and guess if you have to. There's no penalty for guessing. In fact, if you can rule out the worst possible answers, you improve your chances a great deal. The last several of the multiple choice questions will be picked 2, where you've got to select 2 correct answers for each one. And so we'll have the same thing on my tests. Read all of the instructions all the way through. A lot of them are almost like they're testing you for your ability to read instructions thoroughly. Part 2 is free response. 5 questions for AP Physics Part 1, 4 for Part 2. No one knows why. Each is broken into multiple parts, like Part A, Part B, Part C. Don't leave any blanks. If you can't handle Part B, go on to Part C. Each part of the question is its own thing. You can even say, assume the answer to A was 19. Now for B, just go on like so. Because each of them is testing for a different part of your understanding. Taking notes is going to be important. You got a PDF textbook, but everything you need will be given to you in your notes. So that's your real textbook. You're making it as you go along. 2-column notes are good, but really you can follow your own style. There is scientific evidence that writing it down, like writing it down for reals, not just with a keyboard, helps you to learn and to understand the material. So some initial steps. Get the syllabus. It's on the website. Get the textbook, OpenStax College Physics for AP Courses. Read and understand the safety form. That's part of the syllabus. You're going to need to sign it, have a parent or guardian sign it, take a photo, and submit it online. It's like an assignment. And you should do the same for the contract for physics with Mr. Stroop. Both of those are required. The contract is basically saying that you understand the material about academic honesty and what you need for this class. Other initial things you need to do, you're going to have to log on to your College Board account. We'll talk about this more in class. It's the same one that you would use, for example, to look up an AP score, and sign up for this class with the join code that you'll be given. You can and should sign up for the AP test at the same time. Payment's going to be handled later. The school's done a really good job of making sure that everyone can take it. You will have to be signed up for the class in the AP College Board system for some of the things we're going to do, and there is no charge for this. Paying for the test is totally separate from signing up for the class on the AP site. Okay, that's it for now. Start on those basic steps. Check on Canvas for the things that you need to download and how to submit them. And then we will get started with our first unit.